In this video, we are going to talk about the chapter 5, the discrete probability distribution. Okay, first of all, we talk about what is the probability distribution. All right. So before we start the probability distribution, let's talk something about the random variable. A random variable is a variable whose values are determined by chance. We choose random variable from sample space, but the random variables usually denoted by x or y, z, like that. Okay, the uppercase x, uppercase y, and uppercase g. And there are two types of random variable. One is the discrete random variable that takes countably many or countable number of values, and another is the continuous random variable. Continuous random variable takes uncountably many. So there are many values for continuous random variable. For the discrete random variables, there are many, but you can count them. Okay, we will see some examples, and that things will be clear. Example number 1: a dice is rolled. Okay, let x denotes the number of dots on the top of the dice. So we are denoting x as the number of dots on the top of the dice. So how many dots? You write, if you see one dot, you write 1. 2 dots, you write 2. 3, 4, 5, 6. So these are the possibilities for x, because x denotes the number of dots. Okay, so we say that x is a random variable. Here it is a discrete random variable because it is taking just 6 values there. Okay, then x can be one of the 1, 2, 3, 4, 5, 6. Number 2, 3 coins are tossed. Let x denotes the number of heads. If you toss 3 coins, what do you get? So if you toss 3 coins, then the sample space will have like this, right? You either all of them have head, or the first had head and the second has head and third has tail. The first has head, tail, and then head, and then tail, head, head, right? And then head, tail, tail, right? And then tail, head, tail, and then tail, tail, head, and then tail, tail, tail. These are the possibilities, right? When you toss coins 3 times, or 3 coins are tossed together, then this is the number of outcomes. These are the total possible outcomes. But if you denote x by the number of heads, let us denote number of heads by x. Okay, then how do you write that x? Then x will be number of heads. How many number of heads are there on the first one? 3, right? On the second one, 2. Third one, fourth one, there are 2 heads. Okay, and how about how many number of heads on those 5th, 6th, and 7th? 1, because we are denoting x for number of heads, right? Number of heads are denoted by x. So either there will be 3 heads, or 2 head, or 1 head, or 0 head, because on the last one there is no head. So these are the possible values of x, because x is denoting the number of heads when 3 coins are tossed. So we'll list all possible values of x, and then that x is the random variable here. This x is a random variable on this problem. Okay, let us do a couple more examples. 2 die are rolled. There are 2 dice rolled. So what are the outcomes look like? If 2 dice are rolled, then outcomes will look like, the first one will show 1, second will show 1. First show 1, second show 2, and so on. First show 1, second show 6. Similarly, the first die shows 2, second die shows 1. First die shows 2, second shows 2, and then so on. 2, 6. And then similar way, first die shows 6, 1, 6, 2, and then up through 6, 6. So this is what you get, right, when you toss 2 dice. But what does x denote though? X denotes the sum of 2 numbers. X denotes the sum of 2 numbers. So x can be what is the smallest sum? That will be this one, right? 1 plus 1 will be 2. The smallest sum will be 2. The another sum is 3 is possible. Similarly, 4, 5, 6, 7, 8, 9, 10, 11, and 12 are possible, right? But 13 is not possible, because the biggest value in one dice can be 6, and biggest value in the other dice can be 6. So 6 plus 6, 12 is the biggest possible, and 2 is the smallest possible values for the sum of the top of the 2 dice. Okay, 2 dice. So that is the random variable x on this problem. In a family of 3 children, let x denotes the number of girls. So how many girls can have? X is the number of girls. So there can be all 3 girls, or 2 girls, or 1 girl, or 0 girl, right? These are the possible values of X, which denotes the number of girls. Or number of boys also, you will get the same numbers. Okay. What are the possible values for X? These are the possible values of X. These are the, so in all these examples, X is the random variable. The next thing is the discrete probability distribution. So a discrete probability distribution consists of values of random variable. These are the values of the random variable, and that can assume and the corresponding probabilities. So we write in a table, in a distribution, we write values of a number the random variable denoted by X, and then we write the probability of those X. For example, when you roll a dice, what are the let X denote the numbers on the top. It could be 1, 2, 3, 4, 5, 6. These are the possible values for X if X denotes the number on the top when you roll a dice. Okay. Now, what is the probability of getting 1 dot? Is 1 over 6, right? See, we write in a table, we write the random variable and its corresponding probability. Okay, the value of the random variable and corresponding probability. What is the probability of getting 2 dots? 1 over 6. Probability of getting 3 dots is also 1 over 6. 4 dot 1 over 6. 5 dot 1 over 6, and 6 dot 1 over 6. And you see that, so all these probabilities are between 0 and 1, right? And all these probabilities are less than 1, and all these probabilities are greater than 0. If one of these are less than 0, then we don't call the probability distribution. Also, what is the sum of the probabilities there? Sum of the p's. 1 6 plus 1 6, 2 6, 3 6, 4 6, 5 6, 7 6 6. That is, the sum of the probability will be 1. So this is basically the properties of the probability distribution. So all these probability must be greater than 0, less than 1, and then the sum of the probabilities must be 1. Sum of the probability of all values of X, okay, must be 1. Then it is the probability distribution here. Okay, let us talk about that. We can represent discrete probability distribution in a graph. The random variable should place along x-axis and the corresponding probabilities should be along y-axis. Let us see example number 6. 3 coins are tossed. Do you remember what were the outcomes in the sample space when 3 coins are tossed? Write the outcomes in the sample space. So we did H, 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 right? H, H, T, H, T, H, T, H, H, right? And then H, T, 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 H, T, 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 H, and then T, T, T. So T stands for tail, and then H stands for head. Okay. Now, the construct of probability distribution for the random variable which represents the number of heads. So you want to write X is the number of heads. So what are the possible values of X? It will be 3 head, or 2 head, or 1 head, or 0 head. So how many outcomes? So what I want to do is I want to write the probability of 3 heads. Okay. So what I want to do is I want to make a probability distribution X and then the corresponding probability. So X can be 3 or 2 or 1 or 0. These are the values of X. We just find out, right? What is the probability of 3 heads? How many items, how many outcomes have 3 heads? This is only one, right? So you write 1 out of 8 because the total number of outcomes is 8. How many outcomes have 2 heads? So 1 outcome, 2 outcome, 3 outcome. These have the 3 heads. So it will be 3 over 8 because there are total 8 and then 3 of them have 2 heads. How many outcomes have 1 head? 1, 2, 3. So that will be 3, 8 again. And how many outcomes have 0 head? That will be 1 over 8 because this outcome doesn't have any head. Okay. So this is the probability distribution for the number of heads when you toss 3 coins together. Okay. Now, I want to represent this value by the histogram, or you say that bar diagram, I would say. Okay. So you can do that too. How do I do that? Is what it says is you should place the random variable along x-axis, okay, and corresponding probabilities along y-axis. Look at that. So what is the probability of 0 head? Is 1/8. So 0 head, the height is 1/8. I wrote this 0 in the middle. I wrote that, and then I write the bars of equal width. You see that? And the height of 0, the P is the height of X values. Okay. For 0 it is 1/8. For 0 it is 1/8. For 1 it is 3/8. Look at that. This is 3/8 height. For 2 it is 3/8 2, and then for 3 it is 1/8. So this is basically the kind of histogram, but along x-axis we done in the histogram. If you remember that in the histogram, what we used to do is we used to write the class boundaries, right? But you don't have to do that here. What we do is you write down the values of x, the random variable, along x-axis in the middle, and around that value you draw a rectangle, okay, and the value of the p basically denotes the height there. Okay, let us do one more example here. What it says is 2 die are rolled. Let x denotes the sum of the number on the top. Construct the probability distribution for the random variable which represents the sum of the numbers on the top. Okay, let me first write down what is the sample space. So the sample space will be 1 1, right, 1 2, right, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, and then 1 comma 6, right? And then similarly the first die can be 2, second die can be 1, 2 2, similarly 2 3, and then up to 2 6. You see that? Similarly you have 3 1, 3 2, 3 3, and then up to 3 6. Okay, continue that way. What you get is 6 1, 6 2, 6 3, and then 6 6. These are the all possible outcomes. Okay, now what is the random variable x? X is the sum on the top, meaning 1 plus 1. So it can be, the smallest value is 2, and then it can be 3. How many have 3? Sum 3. There are 2 outcomes that have sum 3, right? One outcome with sum 2. So 3. How many have sum 4? 1 3, 2 2, and 3 1. So some can be 4, some can be 5, 6, 7, 8, 9, 10, 11, 12. These are the possible values of x. Okay, so what are the probabilities? So we'll find out the probabilities too. So let us do, what we can do is you can write x and then p like this. Okay, and then write the corresponding value of x and the probability. So 3 4 5, or list all these values: 6 7 8 9 10 11 12. Can you tell me how many total outcomes will be here? That will be 36. So how many have sum 1? Sum 2, that is 1 1, that is 2, right? So that has sum 2, meaning only one outcome. This is one outcome, this is another outcome, this is another outcome, because you are rolling 2 dice, right? So these are the numbers show up on the top of each dice. Okay, 1 1 1 2, like that. Okay, so how many outcomes have sum 2? Only one outcome. So you write 1 over 36 is the probability. How many outcomes has sum 3? Have sum 3, that is 2 outcomes. So we did 2 over 36. Similarly, you will get 3 over 36, 4 over 36, 5 over 36, and 6 over 36. That has sum 7. What are the one that has sum 7? That will be 1 6, right? That will be 2 5, right? And then that will be 3 4, sum 7. Okay, similarly that will be 4 3, right? And then 5 2, and then 6 1. So there will be, so 1 2 3 4 5, because there is one more left there, and then 6, right? So 6 over 36. How about the sum 8? What are the outcomes with sum 8? That will be 2 6, right? And then 5 3, right? And then 4 4, and then 3 5, 4 4, 5 3, and then 6 2. That will be just 5. So 5 out of 36. If you count others too, that will be 4 over 36, 3 over 36, 2 over 36, and 1 over 36. You see that it goes up, it increases, the probability increases up to 7, and it starts to decrease. Okay, now how do I draw the histogram or the bar plot for that? Is there is 2, there is 3, let's say 4, 5, 6, 7, 8, 9, 10, and then 11, and then 12. Make sure that all these are equally spaced. Okay, so on the, what is the highest probability? Is 6 over 36. This is 1 over 36, 2 over 36, 3 over 36, 4 over 36, 5 over 36. So that is 5 over 36, 6 over 36. Okay, 1 over 36, 6 over 36. Okay, now how many has the sum 2? That is 1 over 36. The probability is 1 over 36. So I want to make this 2 in the middle. So 1 over 36, right? So another one is 2 over 36. You write like this and then do that. Another one is 3 over 36, like this. 4 over 36, like this. And then 5 over 36, like this. And then 6 over 36, that is the highest one. Now it starts to decrease. Okay, you get that 5 over 36, and then 4 over 36, 3 over 36, 2 over 36, and then 1 over 36. You see that? It looks like a symmetric, right? It looks like a symmetric distribution. Okay, so this is how we draw the graph of a discrete probability distribution. So first of all, you need to have the probability distribution table. You need this one. Okay, first list all the possible values of x and find the probability for each of these values. That is the probability distribution table. Okay, but how did I find out x, the random variable, is from the sample space? And then after you do that, along x-axis you write down the values of x, and along y-axis these are the probabilities. So 6 over 36 there. Okay, this is how you draw the graph. Okay, let us write on the note. The sum of the probabilities of all events in a sample space add up to 1. You see that? If you add all these numbers, you will get 1. Because you see that 1 plus 2 is 3 plus 3 is 6 plus 4 is 10 plus 5 is 15 plus 6 is 21 plus 5, 26 plus 4, 30 plus 3, 33, 34, 35, 36. So the total is 36 out of 36. That is 1. The sum is 1. Sum must be 1. And each probability is between 0 and 1 inclusively, meaning probability of, and all these probability must be greater than or equals to 0 and less or equals to 1. Now from this feature you can just find out which of these are probability distribution. Let us look at the first one. All the values are between 0 and 1. Okay, and then all of these, let's see the sum. 0.6 plus 0.2 is how much? 0.8 plus 0.1 is 0.9 plus 0.3 is greater than 1, because it will be 1.2. So it is no. How about this? 1/4 is basically 2/8 plus 1/8 is 3/8 plus 3/8 is 6/8, 7/8, 1/8. This is yes, because all the values, all the probability values are between 0 and 1 inclusive, right? And then the sum is 1. How about this one? The sum is 1, probabilities are less between 0 and 1. So it is yes, and this is no. Why no? Because there is one negative value there. Okay. Also the sum is not equals to 1. All right. So let us look at example number 9. At a drop-in mathematics tutoring center, each teacher sees 4 to 8 students per hour. The probability that a tutor sees 4 students. Let us say that x is number of students, okay, of students. The instructor sees in an hour. So what are the possible values of x? It says 4 to 8 students. That will be 4, 5, 6, 7, 8. These are the possible values of x. That's what the question says, right? Now the probabilities are given there. So let us write down x and then p. We write p or px, okay? Probability of x, that's what it means. What is the probability that the teacher sees 4 students? Is 0.117, 0.117. What is the probability that the teacher sees 5 students? Is 0.112, 0.112. 123, I'm sorry. It is 0.123. So 1, 2, 3. Okay. What is the probability that the teacher sees 6 students? Is 0.295. What is the probability that they sees 7 students? Is 0.328. These are the given values. Find the probability that a tutor sees 8 students in an hour. Construct probability distribution and draw the graph. So what is the probability that he sees 8 students in an hour? So we are assuming that this is a probability distribution. Okay, so to find out that, let us say this is, say, lowercase p. Okay, since this is a probability distribution, what you need to have is the sum of all these must be 1. Okay, so it should be 0.117 plus 0.123 plus 0.295 plus 0.328 plus p must be 1, right? I'm assuming that the missing probability is p. Now what you do next is you need to add all these values that is on the left side. So the sum on the left side is basically 0.863. So 0.863 plus p equals to 1. Now subtract 0.863 on both sides. 863. So what do you get? That will cancel out. So the probability, the missing probability is basically how much is the missing probability? Is 0.137. So 1 minus that is 0.137. This is the probability distribution with the new value is 0.137. It says also draw the graph. So you can draw the graph as, how do you draw the graph? Is you mark 4, 5. So that will be, let me write down 5. It's not working basically. 5, 6, 7, 8, right? And then how do you draw the graph? There is, look at this. So 0.117, 0.123, 0.295, 3. So the biggest one is like 0.33, right? So what you do is 0.1 here, 0.1, 0.1, 0.2, and 0.3, 0.3, right? And maybe 0.35 here. So you just do the rough estimate there. For 4 there is 0.117, is like 0.11, right? So you do a little bigger than that. And then another is 0.125, 123. So it is almost that, but a little bigger than that, right? And what is the next one is 0.295, is almost like 3. Another one is 0.328, that is almost like 0.33. The last one is 0.137, right? So 137 will be somewhere here. So this is the graph of the probability distribution here. Okay guys,